Okay, hello everyone. Myself Venu, lecturer in mechanical engineering from Government Polytechnic Varangal, and subject dealing about refrigeration and air conditioning. And today's topic is psychrometry. Okay, psychrometry is a new topic in this today's video session. In last few video sessions, if you observe, so mostly we have concentrated on the total complete refrigeration part, and additionally we have seen the basics of or fundamentals of some air conditioning and equipments of air conditioning. Next we will start this a new topic and new chapter in this video session, that is psychrometry. We'll see what is a psychrometry and what are the some psychrometry related terms. So why this psychrometry is useful in air conditioning or some cooling load calculations, cooling and heating load calculations, and in heating, ventilation and air conditioning. So why this what is this term, and why it is there is a need to study this topic in air conditioning. Okay, so let us move into the topic. So coming to the objectives here in today's class, so after this completion of this today's class, so you would be able to understood what is the psychrometry, and some psychrometry related terms also discussed in this today's video session. That is regarding humidity, relative humidity, DPT means the dew point temperature, DBT and WBT, it means dry bulb temperature and wet bulb temperature. So we will see all these terms and importance in the air conditioning. Absolute humidity, humidity ratio. Okay, so we will discuss all these terms in this today's video session. First we will move on to the psychrometry. So what is this psychrometry? Just in a simple sentence, so it is a branch of science. Again, it is a just like you're studying on something, like what you're studying. So you're studying regarding the mixture of dry air and water vapor. So whenever the combination of that dry air, when the changes of the percentage of the water vapor will take places at different stages. So what is what happening behind that? What happened when this mixture will take place? So it is a branch of science which deals with the study of the mixture of dry air and water vapor. Okay, dry air and water vapor. So this is regarding the psychrometry. And if you know, if you want to study the regarding the psychrometry, before that you have to know regarding the atmospheric air. Whatever the air which is present in the atmosphere, generally if you observe in some some seasons or at some place changes in the different places, there will be change in the combination of the dry air and water vapor. So it is a mixture of the dry air and water vapor, so along with the combination of some gases also. So now the dry air denotes a simply atmospheric air without water vapor. So clearly explaining what is the dry air here, it denotes a simply atmospheric air, but without water vapor it is represented as a dry air. Whereas if you know what is water vapor means, so in that air, when it contains some moisture content, air which is containing the moisture content is known as a water vapor. So you got the two terms, that is dry air and water vapor. So mixture of these can be taken as atmospheric air, and what the study you are making on that particular combination or particular mixture, so that can be taken as psychrometry. So hope you got some information regarding what is the psychrometry, what is atmospheric air, what it is containing, and what the study you are making, and why this is named as psychrometry. Nothing but something study on that, right? So here the psychrometry is essential in applications of air conditioning principles. So we'll see what are those air conditioning principles, such as the AC systems, air conditioning systems normally used in a lot of application, a lot of different uses, like mostly in households or in industries, offices, hotels, schools, colleges. So most of them utilizing these air conditioning systems, and this also requires some cooling load calculations, where depending on the room capacity, and how much, depending on the effect, it means how much quantity at the different seasons, what are the dry vapor, the dry air and water vapor mixture. So cooling load calculations, the design of cooling towers and evaporators, etc. Design of cooling towers and evaporators, etc. So these are the applications of air conditioning principles, where this psychrometry is essential here in these cases. So coming to the terms, so this is regarding a brief introduction to the psychrometry. Next, coming to the terminology, so a lot of terms you have to discuss before we going to study more detailedly about the psychrometry. So the psychrometric terms are humidity or relative humidity, is shortly it is named as RH, and dew point temperature DPT, dry bulb temperature and wet bulb temperature, it is DBT and WBT. Absolute humidity, humidity ratio. So see the terms which are related to humidity. A symbol humidity, next relative humidity, next absolute humidity, next humidity ratio. So all these terminology are different. So let us just we move on to the we will see some psychrometric terms. So one by one, then you will get some additional information again. Just we have focused on some basics of the psychrometry. Now you will get if you study these terminology, additionally you will get some more information. First of all, we will see what is the humidity. Okay, just we go through this sentence, then you can get some idea what is the humidity. So here the sentence is like, what is the humidity means? It is the ratio of the mass of water vapor in the moist air per unit mass of dry air in a given volume. So hope you have got that sentence. It's the ratio of mass of water vapor in the moist air. So whatever the moist air is there, dry air is different, moist air is different. So in the moist air, what is the mass of water vapor present? Per unit mass of dry air, in a given volume. Per unit mass of dry air in a given volume. Just we will see the how it is denoted. Is denoted with capital W, humidity. So in other terms, it can also be called as specific humidity or humidity ratio. Specific humidity or humidity ratio. So where you can see the mathematical form of that specific humidity, W equal to that M suffix V small v by MA. Okay, so it is the mass of water vapor in the moist air to the mass of dry air in a given volume. So MV by MA, which is equal to specific humidity. Now what is MV means? The weight of water vapor or mass of water vapor in kgs and mass of dry air in kgs. Okay, so when you multiply into G, you will get the weight of that in newtons. So this is regarding the humidity and or specific humidity or humidity ratio. So in terms of the pressures, so we will have the formula like this. The humidity ratio W equal to 0.622 PV by PB minus PV. So this is the formula, you please try to remember. 0.622 into PV by PB minus PV. When the air is fully saturated, so W equal to 0.622 if it is saturated, PS by PB minus PS. Means we'll see what is the terminology. Remember that when air is fully saturated, the value W equal to 0.622 into PS by PB minus PS. Now we'll see the terminology. What is the PB first? So it's a barometric pressure, so which you are directly measuring with the help of an instrument, that is a barometric pressure. And so PV equal to vapor pressure, PS is the saturation pressure. So these are the terminology or the formula, mathematical formula for the humidity ratio or specific humidity, or simply terminology humidity, which is denoted by capital W. So remember that formula, or simply we can write that as mass of water vapor present in moist air by mass of air in a given volume. So mv by ma, we know that values directly, then you can get what is the humidity in air. This is the first term. Coming to the second terminology, relative humidity, which is denoted by phi, or simply you are writing it as a short form as RH. Now we will see the statement regarding this. What is relative humidity, RH value of air? So it is the ratio of actual mass of water vapor in air at a given place to the maximum mass of water vapor the air can hold at same temperature and pressure. It means but at a given place, how the ratio you are taking means, it is also taken as in the form of a ratio. First, what you are considering, actual mass of water vapor in air at a given place. So now, for example, if a particular place you have to measure the relative humidity, so what you have to consider, the first thing is, what is the actual mass of water vapor present in the air at that place. Okay, how much actual mass of water vapor present in air at that place to the maximum mass of water vapor the air can hold at the same temperatures and pressure. Again, at that same place where at the same temperature and pressure, actually that particular air, how much amount of maximum mass of water vapor it can be hold. Hope you got that point. Okay, so that is denoted by phi, so which is equal to mv by ms. So it is also defined as in other form in terms of pressures. So it is the ratio of actual pressure of water vapor in moist air to the saturation pressure of the vapor at the same dry bulb temperature. So this is also other definition regarding in terms of the pressures. Okay, so now this can be written as phi equal to PV by PS. Okay, PV by PS, and mostly they are expressed as percentage. It is denoted by phi or RH, but they are expressed as percentage, like 60%, 70%, 80%. These value will affect depending on the season, depending on the different seasons, like winter season or summer season, like that. Now for example, here we are taking that 50% RH means at a given temperature the actual moisture present in the air is 50% of the maximum moisture that air can hold. For example, maximum moisture in that air at the same temperature and temperature, for example, if it can hold 80%, that is the maximum. The actual moisture present in the air at that particular time, at that particular pressure and temperature is 50%. So that condition can be taken as a relative humidity to measure that in terms of percentage. So this is regarding the second terminology in this psychrometry. Next, very interesting term, that is a dew point temperature. You know that dew, where it readily to condense, ready to get condensed at that particular temperature, that is a dew. You will see that in a statement here, the dew point temperature, the temperature at which the water vapor in the air just begins to condense. So what I told, just it will start to change its phase to condense, change its phase to liquid form, vapor to liquid form. Again the statement, the temperature at which the water vapor in the air just begins to condense. Condense means changing its phase to water vapor to liquid form. Now when atmospheric air gets saturated with vapor, vapor pressure decreases and excess moisture condenses to droplets of water. So I got that point. When atmospheric air gets saturated with vapor, when it starts saturation process with the vapor, what happens is the vapor pressure gets decreased, and whatever the excess moisture is there, it will start condensing to droplets of water. Now the temperature of the air which is measured at this condition or at this point is called as saturation temperature or dew point temperature. Named shortly, it is named as dpt. Okay, it is named as dpt. Temperature of air at this point is called saturation temperature or dew point temperature. So this is regarding the third terminology, that is a dew point temperature, where to remember that word, where it is readily starts to condense. Next, other terminology is the dry bulb temperature. Okay, the dry bulb temperature. So just here simply you can identify that. So it is the temperature recorded by an ordinary thermometer. Just to take a simple ordinary thermometer which is used to measure the temperature. So whenever the temperature recorded by an ordinary thermometer, so that temperature can be referred as dry bulb temperature. So generally it is denoted by T suffix D, capital T suffix small d. In the same similar case, what is wet bulb temperature? Most of the times these two terminologies are repeated again and again. DBT, WBT, DBT and WBT. Like, what is it? How the WBT means wet bulb temperature. So it is the temperature indicated by a thermometer, where at end of a bulb of a thermometer is covered with the wet cloth or wet wick. It is covered with that, and whatever the temperature measured, so when it is placed in the air or whenever just to measure the temperature, so whenever they are rounded in the surrounding air, due to its presence of the wet wick or wet cloth, temperature indicated by the thermometer, it may be a different one. So that temperature can be recorded as wet bulb temperature. So here this WBT is constant as long as the total heat remains constant. Whatever the total heat is there, that heat, if it remains constant, wet bulb temperature will shows the temperature as a constant value for a longer time. If it changes, the total heat value get changes, the WBT will also changes there. So it is denoted by capital T suffix W. Now you observe one point here. Due to the wet wick or wet cloth is provided around the that bulb of a thermometer, when you place in the atmosphere, it records the lesser temperature when compared with the dry bulb temperature. Remember this point, TW is always less than the TD value when you measure with the given conditions, dry bulb temperature and wet bulb temperature, how it can be measured like that. Now the difference between the dry bulb temperature and wet bulb temperature is called wet bulb depression. Okay, where you can see the change in the temperatures. As you know that DBT is having higher temperature than the WBT. So when you take the differences between these two temperatures, the term is, it can be taken as the difference obtained of these temperatures is wet bulb depression. That is WBD, wet bulb depression. Okay, so remember these points, very important. Next we will see the continuation, that is absolute humidity. So hope you have understood regarding this terminology. We are seeing one by one. That is humidity, the relative humidity, dry bulb temperature, wet bulb temperature, and we'll see the continuation. That is, next one is absolute humidity. Continuation, the absolute humidity, we'll see from this statement, amount of water vapor present in a unit volume of air is called absolute humidity. So how absolute humidity can be measured? So how it can be taken, here you can see from the sentence, the amount of water vapor present in a unit volume of air. When you're taking the unit volume of air, how much amount of water vapor is present in that can be taken as absolute humidity. So here it can be measured in the grams per meter cube of dry air. Meter cube in the sense giving the value of the unit volume. So grams means how much amount of water vapor. Amount in the sense we are measuring in terms of mass, that is grams per meter cube of dry air. So that it representing as a absolute humidity, so where it is also termed as vapor density, absolute humidity or vapor density. And density, why you are named as density means generally you know the units of density, grams per meter cube or kg per meter cube, like that, and they are denoted by rho suffix v, small v, rho suffix v. Now in the continuation we will see that rho v equal to 1 by v of v. So it is a density of water, where this v suffix small v is representing the specific volume of vapor in meter cube per kg. So you know that density, that is a specific volume, is a reversal of that, meter cube per kg of dry air at its partial pressure PV, whose value can be read from the Steen tables in kg per meter cube, corresponding to PV and TD. It means the pressure, vapor pressure, and temperature, that is the dry bulb temperature. That partial PV can be taken as the partial pressure of vapor, TD is the dry bulb temperature. The next terminology, that is the degree of saturation mu. Now, so it is defined as the ratio of the mass of water vapor m at a given temperature So it is defined as the ratio of mass of water vapor taken as m at a given temperature in a unit mass of dry air. So the condition, if you see up to this part, again it is taken as the ratio mass of water vapor at a given temperature in a unit mass of dry air. So that is up to the first condition. You are taking this value in the numerator to the mass of water vapor in the unit mass of saturated air. That is a saturated air at the same temperature. Just at the normal condition you have taken. Next thing is this, at the saturated air you have taken. Unit mass of dry air for the first case. Unit mass of saturated air is the second case. At the given temperature or the same temperature. So degree of saturation will give as taken as mu, which is equal to m by ms. It is the mass of water vapor in different cases, that is in a mass of dry air and in mass of saturated air, where if P is the total pressure of moist air, so which is equal to PA plus PV, which is the PA is the partial pressure of air and PV is the partial pressure of water vapor. So A is representing the air, V is representing the vapor, water vapor. Partial pressure of air PA, partial pressure of water vapor is the PV. So it is the total pressure of the moisture, that is the sum of PA plus PV, where this P is the partial pressure of water vapor when air is fully saturated. So S representing the saturated air, that is a fully saturated. Now we take the relation between the PV, the WVT and DVT. So the following empirical relation or carrier equation, mostly it is very important, will give the relation between the partial pressure of water vapor at fully saturated stage, wet bulb temperature and dry bulb temperature, that is carrier equation. So here you can note it down, the carrier equation, where PV is equal to PSW, we will see all this terminology, minus PB minus PSW into TD minus TW into 1.8 by 2800 minus 1.3 into 1.8 TD plus 32. Now where this PV is the partial pressure of vapor, PSW is the saturation pressure corresponding to wet bulb temperature, and you know that PB equal to barometric pressure, and TD is the dry bulb temperature, TW is the wet bulb temperature in degree centigrade. So that is regarding that carrier equation. You please try to remember that equation. where it will give the relation between the wet bulb, dry bulb temperature and partial pressures of water vapor. Next one is the enthalpy of the moist air. Enthalpy of moist air or air which is containing the water vapor. What is the enthalpy? So here the statement or the relation you can write here, where the enthalpy of a mixture of dry air and water vapor. So here you can see the relation where it is denoted by capital H, enthalpy, so which is equal to 1.005 TD plus small w into 2500 plus 1.88 TD. So where they are expressed in kilojoules per kg of dry air. Now where W is the mass of water vapor in 1 kg of air, that is a specific humidity, and where TD is the dry bulb temperature in degree centigrade. So this is regarding that topic. And so continuation we will see simple problems regarding in this. So hope you have understood this terminology up to this part, to the enthalpy of moist air. Continuation we will see the problems, and next we will see some the equipments, or you can take some the apparatus which are used to measure the dry bulb temperature or wet bulb temperature, psychrometers. We will see those equipments. Meanwhile we will see the simple problems here regarding what we have seen, the mathematical formulas of different cases. So this is the question. So for the given problem, so just you have to find out the specific humidity, calculate the specific humidity. So hope you can revise this theory part, and you can see what is the formula of the specific humidity, or simply the humidity, okay, or humidity ratio. We'll see that. So given thing is here is to be the air supplied in a room having a temperature of 17 degrees centigrade, and relative humidity percentage is 60%. Barometric pressure is given as 1.0132 bar. They are asking to find out the specific humidity. So that you know that relative humidity represented by phi and expressed in percentage, that is 60%. Barometric pressure is given, and saturated vapor pressure at 17 degrees centigrade. Here that pressure you can note from the steam that refrigeration tables, where you can see that of this particular vapor, water vapor, the temperature is 17 degrees centigrade, and saturated pressure can be taken as 0.01936 bar. So where you are taking from the steam tables. So this is saturation vapor pressure at 17 degrees centigrade. So as you know, the relative humidity phi equal to PV by PS. This is the formula where you can find out the partial pressure of the vapor. So which is equal to, you multiply with that given values. 0.6 is the relative humidity percentage, that is 60% written in 0.6 numerical value, into 0.01936, which is given the partial pressure at a saturated pressure. So you will get the value 0.011616 bar. Now continuation, what is the specific humidity? So we have the formula in terms of the pressures. W equal to 0.622 PV by PV minus PV. You know the barometric pressure and you know the PV value. So if you substitute all these values, you will get specific W value, humidity as 0.007213 kilojoules per kg of dry air. So it's a very simple problem. Continuation, this is a problem 2. You can read for a while. Okay, so this is the question. So the air which is given, the moist air at a temperature 28 degrees centigrade, they are asking to calculate the relative humidity RH value. So you know that again, that RH is your expressed in percentage, denoted by RH phi, and degree of saturation also, that is a mu value. So we have seen that formula, mu degree of saturation. Now the given cases are dPT is given as 14 degrees centigrade and total pressure is 1 bar. Okay, so So from the steam tables at the 28 degrees centigrade, so we can note down the pressures, the PS and PV value. PS, that is the saturation pressure, you can note it as PS equal to 0.03782 bar, and at 40 degrees centigrade the partial pressure of that water vapor 0.015782 bar. Now RH value, that phi equal to PV by PS, so you can substituting these values, so you'll get phi value as 42%, approximately 42.25%. Degree of saturation formula is mu equal to PV by PS. You can write all this formula, so by substituting that you will get degree of saturation as 0.4131. Next, moving to the next simple, the problem 3. So in a laboratory test, a sling psychrometer recorded dBT as 30 degrees centigrade. So we will see that sling psychrometer in today's session, so we'll get some idea regarding that. So that is a laboratory test where you can measure the temperatures of dBT and WBT. So here the given values are 30 degrees centigrade and 25 degrees centigrade. So they are asking to calculate vapor pressure and relative humidity, third specific humidity, and fourth one dew point temperature. Coming to this, so we will see one by one. So given values dBT and WBT. So at these cases, the partial pressure, saturation pressure at dry bulb PS value is taken as 0.04242 bar, or saturation pressure of water vapor at this 25 degrees centigrade is 0.0366 bar, which is taken from the steam tables. Now barometric pressure is a standard one, it is 1.01325 bar, or okay. So to calculate the vapor pressure, so we have all this relation, already we see this formula. In this, the known values which are taken from some standard from steam tables, or in some cases are directly given in the data. So by substituting that, you will get the vapor pressure PV value equal to 0.0284 bar. And similarly, the relative humidity phi equal to PV by PS. So you know the given values, which are the PV value is vapor pressure, which is calculated, and you have got the answer as 0.0284 bar, by saturation pressure as 0.4242 bar, which is taken at 30 degrees centigrade or at the dry bulb temperature. So values 66 or approximately 67% of relative humidity, RH value. Now specific humidity W equal to 0.622 PV by PV minus PV. So you know the PV value, vapor pressure value, and barometric pressure as the standard one. Substituting all these value, you will get specific humidity value. Finally, dew point temperature. So where the temperature is, that particular temperature, where the condensation, that particular air at that temperature will begin to condense. So the temperature corresponding to 0.0284 bar, it is at the vapor pressure, where it ready to condense is, the temperature is 23 degrees centigrade. The air will start to get condensed here, that is a dew point temperature. So TDP, denoting dew point temperature, TDP equal to 23 degrees centigrade, that is from the steam tables. Okay, so just we move on to the next topic, that is the psychrometers. So these are the instruments used to measure the dry bulb temperature and WBT simultaneously. So simultaneously you can measure both the temperatures, so those are the psychrometers. Okay, we will see the types of psychrometers. So commonly used psychrometers are the laboratory psychrometer, sling psychrometer, aspirating psychrometer, continuous recording psychrometer. So now in laboratory psychrometer, so it's a simple instrument and continuously read the dry bulb and WBT of the surrounding air. Whereas a sling psychrometer, so you can see the line diagram of that, very simple one. So you can see at one side, at the top side, there is a handle provided to that. So there is a wooden frame. So to that wooden frame, two thermometers are connected here. One is an ordinary thermometer which is used to measure the dry bulb temperature, and other thermometer you can see at the end of the bulb of this thermometer. It is covered with the wet wick or wet cloth is provided around that. Then what is the thing what you have to do here? After covering it with wet wick, we'll see in sentences. So as already told, two thermometers are there where they are placed side by side in a frame, given frame, which is completely soaked in the water. So other thermometer is soaked in the water where it is covered with a thin cotton cloth. Now the temperature of air is measured by this thermometer is the wet bulb temperature. Temperature of air measured by ordinary thermometer indicates the dry bulb temperature. So very simple. If you rotate by touching the handle, if you rotate that, so then you can get the temperatures. And so this is regarding the aspirating psychrometer. So you can observe the line diagram of that aspirating psychrometer. So whereas previously we have seen the sling psychrometer, where it contains a rotating handle where it can be used to handle with our hand, and two thermometers. One is to measure the dry bulb and another one is to measure the wet bulb thermometer. So there we are with the help of the handle, just we are rotating that instrument to record the temperatures, where you can get the dry bulb and wet bulb temperatures. Whereas in this aspirating psychrometer, so here you can observe a little advancement here. Instead of rotating in the air with the help of the handle, so here a blower or a fan type of arrangement is placed above the thermometer, so it can be continuous measurement can be made. So this fan connected to the motor, electric motor, and time switch is provided here for checking the temperatures at a regular intervals. For example, if you want to measure in between 15 minutes at regular intervals, so this time switch is utilized for automatic the interval the measurements will taken place. Again, all the similarity you can see the same in this aspirating psychrometer. So in aspirating psychrometer, air circulation can be produced by a small fan mounted at the top. So it circulates the air over the bulbs of the thermometer. So as already I explained all these things, just you can read the statements from this presentation. So here if the air over the bulbs of the thermometer, it circulates over these thermometers continuously, so the accurate results can be ensured from this aspirating psychrometer. And it is also used to measure the dry bulb temperature and wet bulb temperature periodically, so that is at fixed intervals. As I already told, where the time switch is utilized here, periodically, for example at every intervals of 15 minutes, so these temperatures can be measured. For such purpose, the motor is connected to time switch which operates at fixed intervals. Okay, so as I explained that fixed intervals, so operator has to note down the readings periodically. So whenever it taking place automatically, but at every time interval we are fixed in the time switch, so the operator has to take the reading periodically and check at regular intervals or 1 hour what are the changes in the dry bulb and wet bulb temperature periodically can be checked in this aspirating psychrometer, where you can get accurately in this aspirating psychrometer, so compared to the other psychrometers. Okay, so this is regarding the today's video session. So seen the most important topic and a very interesting topic, that is a psychrometer, and related terms we have seen, like some specific humidity, relative humidity, and we have seen like volume specific. Next we have seen based on the different it means the combination of the water vapor with the dry air, So different terminology we have seen, that relative humidity. So here in today's we have seen the terms. So this is regarding psychrometers. Also we have seen like a sling laboratory psychrometer, sling psychrometer, and aspirate psychrometer. So these are the today's video session, and just we move on to the quiz part, and here few more questions will be there, so where you can answer it very easily if you have followed this video session continuously. So you can see for the first question is psychrometer is a branch of science which deals with the the option A, B, C, and you can see it is a mixture of dry air and water vapor. So wet air and humidity is a wrong answer. Water and dry air is also a wrong answer. Not completely water, it's a water vapor along with the mixture of the dry air. The answer you can note it as the first one, A. Next, second question, barometric pressure is denoted by. So generally how it can be denoted, you can easily tell from the P suffix B is the answer. Next, the temperature recorded by an ordinary thermometer is called. So simply using a simple thermometer, and if how the temperature recorded here, so that temperature is noted as dry bulb temperature. So options you can observe here, WPT, DBT, absolute temperature, and DPT. Answer is dry bulb temperature. So the next question, amount of water vapor present in a unit volume of air, volume meter cube. So you got some idea about the amount of water vapor generally measuring grams per meter cube. So I express given the units, and you can easily answer what is the thing here. Answer is specific humidity. Okay, answer is specific humidity, that is the grams per how much amount grams of water vapor per unit volume of air. So the next question, psychrometer measures the following temperature. So very simple, using both the different thermometers, the different arrangement. So wet bulb and dry bulb temperatures, so both can be measured simultaneously by using the psychrometers. Wet bulb depression is wet bulb depression. So I used this term during the discussion regarding wet bulb and dry bulb temperature, right? So it is a difference between both the temperatures, but whichever the higher the value, you have to put it before that and minus the lower value. So at every time I already told that dry bulb temperature recorded is more temperature than the wet bulb temperature. So the answer you can note it down here. Answer is C, dry bulb temperature minus wet bulb temperature. The next quiz, the fan is mounted in the following psychrometer. So I have already seen the line diagram of different psychrometers, two different psychrometers. One is a sling and aspirating psychrometer. So it is advancement of a sling psychrometer, that is aspirating psychrometer. So answer you can note it down, the fan is mounted in the aspirating psychrometer. So coming to the some frequently asked questions, define the following psychrometric terms, that is a dry bulb temperature, wet bulb temperature, dew point temperature, specific humidity, absolute humidity, relative humidity. So they may ask any two of them, three of them, so depending on the weightage of the question. So all the terminology what you have discussed, they are very important in this psychrometry. Next questions, define degree of saturation, explain the types of psychrometers. So these are the few frequently asked questions in this psychrometry. So hope you have understood this today's new topic, that is a psychrometry, and it's a branch of science which deals with the study of the mixture of the dry air and water vapor. Okay, so this is regarding our psychrometry, and seen some instruments and seen some terminology of the psychrometry. So hope you have understood. So thank you for watching, and we will meet in the next video session. So thank you.